Okay. So what we're going to do is going to go through the math of what happened back there with Hank. So you've got a solid sphere, moment of inertia of the solid sphere is 2/5 mr squared. Mass of Hank is 5 kilograms. It's at some height. I don't know what the height is. I don't care what the height is. I don't even care what the radius of Hank is. Don't care. All I know is that Hank is some height above the ground. Now, here's how this problem starts. Your UG at the top has to equal the kinetic energy plus your rotational kinetic energy. Okay? Same idea, because this thing is going to roll as it goes down. This is going to have two different types of energy. So this is going to be mgh. This is going to be 1/2 mv squared. And this is going to be 1/2 I omega squared. Okay? Now, again, I cannot emphasize this enough. If you go to try to put numbers in here right from the get-go, you are screwed. Okay?
Instant explosion.
You are going to lose. You cannot even begin to win. You don't know what the velocity is. Over there, you don't know what the moment of inertia is because you don't know what the radius is. You don't know what the omega value is. Like, you can't even begin.
We know the 1/2s.
Yeah, you know the 1/2s. Okay, great. You know fractions. Yay for fractions. So, there are certain substitutions that you have to do. And this is why I said you work with variables as long as you can. Now, if there was no rotational, you would stop right here. So this would be like Cohen being the only child.
Yes.
All the UG goes to Cohen. Okay? So if it wasn't spinning, this would be the situation. Masses would cancel out. You get V equals the square root of 2GH. Easy peasy, lemon squeezy. Okay? But Cohen has a sister who's going to get part of the inheritance. I'm not saying it's split 50-50, okay? But the inheritance is going to get split, so Cohen isn't going to get as much money. Sorry, okay? Disadvantage of siblings.
Hey, at least it's not going to Teague.
It's not going to what?
Teague.
Okay, I give you that.
In this universe, he doesn't exist.
Perfect. Even
Now,
better.
there are certain substitutions that are critical. When you do this I, that 1/2 out that's out here is not part of the moment of inertia. That's a separate 1/2. Okay? It is a separate 1/2. Do not include that in the moment of inertia calculation. It's a completely separate 1/2. So you got 1/2 solid sphere, 2/5 mr squared. Now, here is the most critical substitution that you have to do on this problem. You have to come in here and go, oh, that's omega. Don't know omega. But I know that omega is V over R, and I substitute that in, and I get V squared over R squared. Cool. Now, at this point, some cool things happen. My R squareds cancel out. This is why I didn't give you the radius of the bowling ball. It doesn't matter at this point. Okay? Now, is there anything else I can eliminate?
That you can multiply your 1/2 to the 2/5?
No, we'll get to that. On both sides, is there a term on both sides of the equation?
E squared? No.
M?
M. Masses cancel out. Right?
I was trying to see if you could, like, pull those out. And
Oh, we
cancel it.
will.
I was like,
So this is GH, right?
that entered my...
This is 1/2 V squared. Now, Cohen, to your point, when I take 1/2 times 2/5, what do you get? Oh, dear
10,
Lord.
1/5. 1/5.
Huh?
1/5.
1/5.
1/5.
If you didn't know that, oh. Okay, I get 1/5, but then out of that, all of that canceling stuff, what do I have left?
V squared.
V squared. So I get 1/2 V squared plus,
1/5 V squared.
so, let's go back to your days of fractions.
Common denominator. Ew.
Common denominator of
10.
10.
Yeah.
This becomes 5/10.
Which becomes, and then plus the 1 is 6/10, which simplifies. I'm stupid. Plus 2 is 7/10. Yeah.
7/10.
I forgot to do the 5 because you're dumb. I'm bad and dumb.
Okay.
Bad boy. Bad boy moment.
Do I know? I want to get this in terms of V. So, Preston, how can I get V by itself?
Times by 7, 10 over 7.
Yep. So to calculate linear velocity at the bottom, what's the only thing I need?
Mass.
No.
No, not mass.
Height.
Need the height.
Height.
That's all I need. Okay? That's the only number that I need. Now, here's the dumbest thing that you can do.
Put a number in.
No,
Even dumber?
even dumber
This is
than
the
that.
wrong answer.
Is
We
go,
solved for the
oh,
next
I'm just going to memorize V equals 7, the square root of 10/7 GH.
one. That only works for spheres.
Yes, it only works for a solid sphere. If it was a hollow sphere, that would have been 2/3 mr squared. If it was a thin hoop, it would be mr squared. So the only thing that you can quote memorize or remember is the process. Okay? Don't sit there and go, oh, I'll just type that into my calculator and I'll have that stored. No. Okay? Bad. So let's say that the height was actually 20 centimeters, about like yay, which is what it was. So the height is 0.20 meters. So somebody take the square root of 10/7 times g times 0.20 meters.
Uh, 1.67.
Cool. Okay? Now, at this point, knowing the mass
Or control delete.
and the height is 0.2, could I calculate the UG that I started with?
Yes.
Because UG is MGH, right? True? So, if my UG is going to be MGH, which it is, so that's going to be my mass of 5 kilograms times G times 0.20 meters. So, go and do that.
I accidentally multiplied by 2, not 0.2. 0.2, 9.8.
9.8?
Yeah.
Okay?
Oh, that makes sense if you think about it. It's 5 and then 1/5.
Yeah. So that's the total amount of energy. So this is the inheritance.
What's what?
Okay? Cohen's uncle was going to leave $9.8 jillion dollars,
Oh,
however much that is.
that's a lot of money, I
Okay.
think.
Yeah.
Of the ground
So-
of the table's left leg.
At this point, could I also calculate the kinetic energy of the object when it hits the ground?
0.
Yes.
Why?
It's supposed to be 0 newtons.
Because you have the total energy it started with, and you
No,
have
no, no, beyond that. So the translational kinetic energy,
equals 1/2 mv squared.
1/2 mv
Oh,
squared.
you know
right?
v, you know m. Just plug them in.
I know my mass and I know my velocity, right? Now, what does my answer obviously have to be less than?
9.8.
9.8. So if I take 5 kilograms
9.8 joules.
times 1.67 meters per second squared, Cohen, what do I get?
1/2
Hopefully a very nice round number.
times 5.
I don't think it is.
Probably not.
Should I pull the whole value for 1.67?
Yeah,
Okay. 1/2.
or whatever is easiest.
Squared. 7.
No,
1/2 times 5.
I know but it isn't exactly 7, is it?
It's 6 point, and then the rest of the digits are 9.
Okay.
It is a very nice round
That
number.
is very, usually, okay.
Yay.
So, if my translational kinetic energy is 7 joules, how much rotational kinetic energy do I have?
2.8.
So my rotational kinetic energy would be
This is why you pull down the full values.
2.8 joules. True? Now, if I know that the radius of Hank is 0.080 meters, could I find my omega value?
Yes,
Why?
because I but squared
You're making this difficult.
and you have R,
You're
so
making this difficult.
I checked all of those. So
Does V equals R omega?
oh yeah, and you know V and you know R.
So my V value is 1.67. So if I divide that, take that 1.67 and divide that by 0.80 radians per second. No, meters, by 0.80 meters.
20.9
Radians per
second.
second. Then you could find your KR using 1/2 and then 2/5 MR squared times
yeah.
omega squared, and you should see that that would be the same thing as that. Okay? All right. So, let's talk about rotational work.
Because it doesn't say in the bottom.
Rotational work.
It also is it. 'Cause I think it's
Spinning is supposed to be fun, not work.
Sorry. Okay. So, what's a simple way to express any work? Change in what?
Momentum.
Dang it.
Kinetic energy.
Energy in general, right?
Yeah.
Change in energy. Change in momentum.
I think he missed that lecture. I think he was retaking a test.
He
No,
just,
I watched the lecture.
he just
Okay.
shouted something out.
If I'm going to make this wheel spin,
You spin it.
I spin it. In doing so, do I apply a torque?
Yes.
Does that torque act through a certain amount of degrees?
Sure.
Sure. And if that torque acts through more of the circle, I do
More spinning.
More.
more spinning. I do more work, right? So, work can also equal torque theta. Okay? Now,
Toe. Sorry.
what are the units for torque?
Newton meters
Yeah.
or joules.
Theta has to be in
Radians.
Radians.
radians. Radians are dimensionless number. Newton meters is the same thing as
Joules.
joule, which is the same thing as work, which is the same thing as the change in the kinetic energy.
It's all connected.
Okay? It is. So,
Damn it.
if you have a force distance graph, what does the area underneath the force distance graph give you?
Work.
Work.
It was the answer this time.
It is. That is. Newton meters, right?
Yeah.
If you have a torque theta graph, what does the area underneath that represent?
Work.
It's the same concept, right? Instead of force and distance is torque and how many radians that moves through. Okay? All right. So let me hand out
It's the assignment that I was looking at yesterday.
this assignment.
It's the bright.
Ooh, it's another mango paper.
Yeah. Where do you get your paper from?
This just down in the pocket.
You just like picking vibrant colors?
Well, it makes it easier for me because if everything was just on the same white paper, I'd always have to go through and sort through titles, and so this way,
Yeah.
It's easier for us too because you can like.
It makes
Our
our
many papers. I can always
Hey,
find
bag
it.
it.
makes our equation sheet look pale.
now this is a new color. I haven't seen this. Technically, this is goldenrod.
I like it.
That's funny because we had mangoes at my house and we I showed my dad this. We cut open one of the mangoes in half, and the exact same color, like exact.
You say, "Hey, Dad, this
same.
paper looks like a mango, right? Let's go test that out." Is that
Yes.
what
Let's
I
test
almost
the theory.
exactly. I was like, Dad, doesn't it look like a mango? And he goes, well, we have mangoes. So we went and grabbed a mango
Was
and
it
opened
good?
it up.
Cut
and
it
it was-
open.
Did you eat the mango?
Yeah,
Is it good?
yeah, mangoes are great.
You know, I used to think I was allergic. Well, I used to maybe be allergic to mangoes, but then I
Okay.
got rid of it.
I'm not
So
really
let
a
me
mango
give
kind of
you
person.
some hints on some of these problems. Okay?
I like papayas.
These are some of my most famous problems that I've developed over the years.
But great.
So, let's start with number 2. Okay? So on number 2, here's the setup.
Oh no.
Oh, yes. Oh, yes.
Hmm?
Some of these I just giggled when I wrote them.
6
Okay.
questions, no
Actually, it's
book
more of an
problems.
evil laugh. There's not a backside to it. There's no book problem.
Jake?
Okay?
Yeah. Oh.
So, visualize this, what's happening on number
man.
2. You have a pendulum that's swinging down. It's already moving.
Okay.
The initial velocity is not 0. So, since it's already moving and it's above the equilibrium point, what 2 types of energy does it have?
But ugh,
UG and
key.
KT, right? Okay, it's going to be moving. True?
It's got some.
Now, when it hits the bottom, what's the only type of energy that it's going to have?
But ugh. Dang it. I mean,
Kinetic?
The kata.
It does the moving thing.
yeah.
The
Well,
kata energy.
yeah.
Okay? So if you take the UG here and the kinetic energy that it has here, add them together, that's going to equal the
At the bottom.
kinetic energy.
The kata.
Sounds like the San Bushman of Western Botswana in the Kalahari Desert. They speak in a series of like clicks and like. And I sat down one time with an old man for like an hour trying to learn some of the language, and he just finally gave up and walked away and said, "You're pretty much hopeless." I said, "Cool." So, no, it's just like, I'm out. Thanks. So,
You
I
probably called
gave
him
you this
something mean.
helpful equation that as this thing swings down, and you all have dealt with this before, that value of H is going to equal L times 1 minus cosine theta. Okay? So let me give you this visual. It's already moving.
Are you sure?
I wrote the problem.
Okay. it's
It's going to
reality
hit
now.
a piece of clay at the bottom. It's going to turn into a California problem. And then they're going to move off like this. So what you're ultimately going to try and find is the angle with the vertical when this is at its highest point. Okay? Cohen, you just laugh.
I
So,
laugh because I'm gonna do it all so bad and illegal. I'm gonna go to physics math jail solving
Good.
this problem.
so
Adult one too.
here is going to be
No.
your thought process.
That process
When
will not
it
be-
moves off right after the collision, so this is going to involve momentum because it's a California problem. So let me give you a hint, because if your answer to 2A is wrong, everything is going to be wrong. Says you want the velocity of 500 gram mass at the point of impact. That answer should be very, very close to 4 meters per second. Because if that's wrong, everything is going to be wrong. Okay? Should be just a skosh over 4 meters per second.
2A or 4A? 2A, right?
2A,
I
I'm
meant
sorry.
to. It was
Yeah, 2A, I saw it before. 2A, the answer to 2A is a little bit above 4. Okay? So, it's going to hit, it's going to swing off together. Now, when it swings up here at its highest point, what's the only type of energy it's going to have? UG. So, the kinetic energy that it has here is going to equal the UG up here. That's going to allow you to find the height. Then you've got to use that h equals L1 minus cosine theta, then you're gonna know the h value, you're gonna know the length, find the angle. So if all goes well, that angle on 2D should be in the mid-40s. Okay? Now, on number 4, which goes all the way through J. That's pretty
So
cool.
bad.
I know, it really, I love
And-
typing this problem.
And H is literally just
This,
determine the
this is
orbital
one
period.
of my funnest problems that I ever developed over the years. So this is just known as a satellite problem. But it's the most applicable, okay?
It's everything.
It is.
It is reality.
It's everything. It goes old school gravity problems, okay?
This makes me want to cry.
Cohen just sits there and just wants to cry. So, let me give you
I'm gonna
kind
cry
of a
real
perspective.
tears when I get home.
When you deploy satellites, you're
Just don't
outside,
stick
obviously,
together.
the
Okay,
atmosphere
just
of the Earth. Otherwise, they can't orbit.
You could
Because
throw
there's
a
too much
spring
air
on
resistance.
this.
So they're receiving direct energy from the sun. So if you don't make them, literally, it's called a barbecue roll. Sometimes it's called the barbershop roll, but it's generally just the barbecue roll because it's like a rotisserie chicken. So you want it to spin so that one side doesn't get really, really hot and the other side gets really, really cold. Okay? This is why you have to do this, or otherwise you're going to launch this multi-million-dollar satellite and it's basically going to freeze or overheat and then you've lost it.
Half cooks and half freezes.
Basically, yes.
It's both at the same
So, I've given you
only at the
it's a cylindrical satellite.
ability.
Because it's a solid cylinder, what are you going to use for the moment of inertia?
1/2
mr squared.
r squared.
So, now, you've got rockets. The rockets are going to fire, and this is going to make this thing begin to spin. Obviously, what's the initial angular velocity of the satellite? 0. You have to get it to spin to 32 revolutions per minute over a period of 5 minutes. Okay? Now, the first thing you have to figure out is the angular acceleration of the satellite. If this answer is wrong, everything else you're going to do is going to be wrong. So your answer to 4a, that value of alpha, should be 0.01 and some change. Okay? Because if that's wrong, everything's going to be wrong. So you're going to have to use, yesterday we talked about this equation, that force times change in mass multiplied by velocity equals your change in momentum. Okay? When you're dealing with how much fuel, mass of fuel you have to have in the rockets, go with that.
Wait, force time equals change in mass minus velocity?
Times velocity.
Times velocity. That looked like a minus and my brain was panicking.
You can't subtract meters per second from.
I'm aware. I am aware. And that's why I was confused and afraid.
Okay.
Your tactics confused and
Some of
frightened
your
me.
answers are going to be really, really big. Like your answers to 4G and 4J are 10 to the 11th. Your answer to 4I is 10 to the 14th.
Wait, you said I is 10 to the 14th?
Yeah. When you get to question 5, that's like that problem that I just did, where you're going to start with UG, it's going to change into translational and rotational kinetic energy. So, good luck. This will be due the Monday after Thanksgiving break.
So 4A was 0.001?
No, 0.01.
Okay, 0.01. 0.01. Okay.
0.01 and some
Wait,
change.
Colin, did you get number 1 and 3 right?
Do not round these numbers, especially on number 4. You have
I don't
good
have any.
data.
I'm gonna
So
try
what
to-
you do not do, especially like on 4A, do not write that as 0.01. Keep lots of digits. All right, go and shut down the camera.